Now let's apply the other interpretation of a fraction. A over b can also be interpreted as eating a slices of pizza out of a pizza that has b total slices. Now, which interpretation is better? It depends on the problem. So you have to hold on to both interpretations of fractions and see what's more convenient for the problem you're looking at. So right here, I have drawn a circular pizza with 3 slices, and this one is shaded in blue to represent that one piece is being eaten. So you see here a picture representing 1/3. Now, let's take each of the existing slices of pizza here, the original three, before this slice was eaten, the one that's shaded blue, let's take each of these 3 original slices and subdivide, cut it further into 2 smaller equal-sized pieces each. So this piece becomes 2 smaller ones, this piece on the left becomes 2 smaller ones, and this piece in the lower right becomes 2 smaller pieces over here. Then you'll have a total of 6 pieces of pizza. Now, how many slices of this out of the 6 will you need to be eating in order to get the same amount of food? Well, keep in mind each of the slices now, if there used to be 3, now there's 6. Each of the slices is smaller, so it's not that we're going to have to, in terms of number of pieces, that number is going to have to increase, right? Even to just get the same actual amount of food. So for the same amount of hungry, you're going to need to eat 2 out of the 6 slices. That will be the same amount of food as 1 out of 3 slices. So you see here now the picture representation side by side of 1/3 equaling 2/6. We'll do another example of this. So here's 3/4. You cut a pizza into 4 equal-sized pieces. Those pieces are not as big as earlier, but they're still fairly big pieces. And if you eat 3 out of the 4, well, what if we subdivide? What if before eating we had this pizza not in 4 equal-sized pieces, but in 8 equal-sized pieces? Now, how many of these littler slices do you need to eat to get the same amount of food? And this should be 6. You see a picture here of 3/4 equaling 6/8. Let's try this idea again, but instead of subdividing each of the original pieces into 2, how about if we subdivide into 3 equal-sized pieces? So for instance, here you've got 5 pieces total to start, and then 2 of those were eaten. You see 2/5 in the picture, and we're going to take each of these individual pieces, all 5 of these, and we're going to, right here, take like this triangular looking piece and cut it twice so that we get 3 littler pieces out of this. In total, we should have 15 slices now. If you count around here, there should be 15. And the number of these that you need to eat will now need to be 6. And visually, you can see that eating 6 out of the 15 pieces ends up being the same amount of food as eating 2 slices out of a pizza that had 5 slices. The pizza diagrams we just looked at showed us that 1/3 equals 2/6, and 3/4 equals 6/8, and 2/5 equals 6/15. So these are just examples, but they lead to the following question and answer. That is, why is A over B equal to A times C over B times C true? The reason this is true actually applies this interpretation of fraction. And what's going on, A over B. Well, that's eating A slices out of B total slices. And the point is that is the same amount of food, that's what the equal sign is about, same amount of food as eating A times C slices, that's what's in the numerator here, out of B times C total slices. That's what this first example, second example, and third equation here of fractions, that's what we are seeing happen over and over. And this sentence, without plugging in any numbers, answers this question right here. This is going to be the only accepted explanation for why this formula is true. So as an example of using this formula, 3/7, the whole point is you can multiply a fraction by the same number on top and bottom, and the value of the fraction remains equal. So 3/7 is equal to 3/7, but multiplying by 10 on top and bottom. And the top simplifies to 30, and the bottom simplifies to 70. Those 3/7 can turn into 30 over 70. If we start with 30 over 70 in our second example, we can, of course, this is not using the formula yet. You can rewrite 30 as 3 times 10. Just replace 30 with 3 times 10 and replace 70 with 7 times 10. And then the whole point is this formula that's up here in the question, it says A times C over B times C can be converted to become just a over c where there's no more c's. So the times c that's on top and on bottom, in this example, a times 10 on top and a times 10 on bottom, those can go away and you just have a over b. You have 3 over 7. This is the thing that people tend to call canceling. The second example is really just the first example in reverse, right? So turning 30 over 70 into 3 over 7 is called canceling. Since you can, what's really going on is since you can multiply the top and bottom by the same number, I mean, we multiplied the top and bottom by 10, this is really just undoing the process of multiplying by 10 on top and bottom. So just some comments about when you can cancel in a fraction. There tend to be a lot of misconceptions when you can do this and when you can't. So I want to try to clarify when cancellation happens in a fraction through some examples, and you're going to want to come back to this several times and we will revisit this. But if you see a times c over b times c, since you have a times in both places and it's a c on top and a c on bottom, meaning that you see the same number on top as you see on bottom, you can cancel the c's. If you see a plus c over b plus c, you cannot cancel the c's. You need multiplication. That is, you can cancel factors, which are things that are being multiplied. You can't cancel terms being things that are added or subtracted. Are you not completely convinced? Well, let's say you start with a fraction 2/5. We actually saw a picture of what 2/5 of eating 2/5 of a pizza looks like, right? So 5 equal sized slices and you eat 2 of them. Canceling a plus 1 on top and bottom would lead to 1/4. And we actually saw a picture of what 1/4 would look like, right? If you cut a pizza into 4 equal sized pizzas and only eat 1, that can't be the same as eating 2 slices out of a pizza that has 5. Right? The issue here is 2/5 is not equal to 1/4, but if you start with 2/5 and you cancel a plus 1 on top and bottom, you'd be at 1/4, and that just really, those fractions are not the same in value. You can check in a calculator. So canceling a plus 1 on top and bottom is an incorrect process. More generally, canceling a plus c on top and bottom is an incorrect process. It's okay to cancel a times c on top and bottom. That's the formula we had just justified. Here's another example. If you see a times c plus 8 over b times c, maybe you think you can cancel the c's here because it says times c times c. Unfortunately, this plus 8 is getting in the way. There's a lot to say about this. The short version right now is to say because c is not a factor of the numerator. This plus sign means what you have is a times c is a term of the numerator and 8 is a term of the numerator. Now, if you see r times s times c over b times c, it's all multiplications. What you can actually do is you can repackage this. You can insert parentheses without changing the value, which is why we've been talking about parentheses so much. So you can just surround the r times s in parentheses without changing the value. And then, because you have a something times c on top and a something times c on bottom, and that's all you have the times c and times c, we can cancel the times c's, and then you're going to have r times s over b. Okay, some more comments about this formula. Again, to cancel, you can only cancel common factors, right? So what's a factor? I really want to clarify that a factor is something that's being multiplied. So take a look here, a times c, a is a factor, c is a factor of the numerator. Down here, you have b times c, so b is a factor of the denominator and c is a factor of the denominator. So to really, really dig into this, this is a question that you can expect to see on a future quiz or exam. It's a super important idea. I want you to not only think of this question for a quiz or an exam, but think about the habit that is meant to be built about fractions. What is the question and the answer to the question trying to really address? So I'll read the question off. What can be canceled in fractions and why? So the only thing that you can cancel in fractions are common factors. That is, common meaning you see the same on top and bottom. And the key word here being factors, right? It's a times c, not a plus c. So common factors, and then let's answer why. Because this is undoing multiplying by the same thing on top and bottom. We had just talked about how if you start with a over b, we justified why this formula is true. You can do a times c on top and on bottom and keep the value of the fraction being equal. That was due to this pizza explanation. You can go back and look at that slide. The point now is to talk about how if it's okay to do a times c on top and bottom, then it's okay to undo a times c on top and bottom. That's why cancellation works, and that's why cancellation really insists on multiplication. We only said it's okay to multiply by the same thing on top and bottom, and all we're doing is undoing that thing that's okay, so that should be okay as well. Notice, in fact, that there's the word factors and the word multiplying in the same sentence. These are connected because factors, by their definition, those are things that are being multiplied. Okay, so let's warm up to a bigger idea we're going to take a look at in just a moment. But what fraction is equal to 2/3 and has 15 in the denominator? Here's an incorrect way to write. Sometimes what I've seen people do is start with 2/3 and then they'll write an equals and say 2/3 and then they'll write a 5, perhaps in parentheses, perhaps not. But people will write this to mean that they're multiplying by 5 on top and bottom and write 10 over 15. Now the final answer, 10 over 15 here, is correct. But the notation is not correct. This really should be 2/3 and then what you write, it's extra writing, I get it, but it's 2 times 5 over 3 times 5. You need a times 5 on top and on bottom, and this ends up being 10 over 15. So be careful how you write this. I want to clarify why what you see in red is incorrect in this red box. The reason I would accept 2/3 and then a 5 in parentheses or not, it's not about the parentheses. It's about writing 5 once. The reason this is a problem, I would accept it if it didn't have its own meaning, but it actually already has a meaning in math. There's a standard meaning. It means something different than 2 times 5 over 3 times 5. What happens is 2/3 times a 5 really means exactly that. It means 2/3 times 5. And 2/3 times 5 just simplifies to something else. So instead, what you really have to do, I insist on it, I will insist on it all semester long, you will need to write 2 times 5 over 3 times 5. If you mean to multiply by 5 on top and bottom, you need to write a 5 on top and write a 5 on bottom.